Good afternoon, ladies and gentlemen. My name is Martin O'Gara of Civil and Structural Computer Services. I'm one of the directors at the company, focusing on the technical aspects of the software development. And joining me today is Mr. Yassin Zabar of Beckhart. Yassin is joining us today as we're delighted to announce the release of a new version of MasterKey Masonry featuring Beckhart products. In particular, today focuses on the bed joint reinforcement products that developed by Beckhart and now featuring in the MasterKey Masonry design. Today we'll be looking at, as I say, we're focusing on some of the new improvements that are coming with the MasterKey Masonry software. The primary one being the introduction of a bed joint reinforcement library. We have 118 different proprietary bed joint reinforcement products now featuring in MasterKey Masonry, all available through a nice, convenient and easy to navigate product library. We're delighted to have teamed up with Beckhart to introduce their Murfor Compact range in the MasterKey Masonry. We're really excited about this product when it was first introduced to us. It's a completely alternative bed joint reinforcement product that comes on a roll. Yassin from Beckhart, who's the technical manager at Beckhart, is going to introduce the product to you and give you an overview of it, and I'll hand over to him in just a few moments. We were instantly impressed with the product. We definitely thought it was a great addition and feature to have in the MasterKey Masonry, bringing this really innovative and exciting new product to our Master Series user base. And in collaboration with Beckhart, we were delighted then to go to work on expanding the reach of the MasterKey Masonry, developed in the UK using European Design Standards BS-EN 1996 Part 1 and 2 for many years. We also then have extended the product to automatically out of the box incorporate an additional European National Annex implementation for 9 countries of all of those listed here. So we've been through all of those national annexes in a lot of detail, implementing all of the various overrides, of which there are many, overriding the ways in which the compression strength is calculated, overriding the ways in which the flexural strength is calculated, and all the other aspects that the national annex is given permission to override. Okay, so we're going to get into explaining and looking at the software and looking at how we've implemented the bed joint reinforcement and talking a little bit more about what actually bed joint reinforcement is, if it's something that's a new concept to you. But for now, I'm going to hand you over to Yassin Zabar of Beckhart, and he's going to give you a little overview of the Beckhart Murfor Compact product. So I'll just hand you over to Yassin. Okay, Yassin.
Thank you, Martin. Yes, great. Thank you very much. Hello, everyone. My name is Yassin, as Martin explained, and I'm a technical manager at Beckhart in the Building Products Division. My specialties are plastering and masonry, and we have been delighted to work with the Master Series to introduce Murfor Compact and other bed joint reinforcements within their MasterKey Masonry design software. I'm going to talk briefly about the company, about Beckhart, and also go into depth about what Murfor Compact is and how it can be used. So Beckhart was founded in 1880 by Leo Beckhart, and it has expanded quite dramatically since then. We now exist in 120 countries. We have almost 30,000 employees worldwide, and we had combined sales of almost 5 billion euros in 2017. And what we specialize in is transforming of steel wire. So we take a raw material wire rod, and we, through different processes in our manufacturing facilities, transform that into different products for different sectors. We also specialize in coating technologies to provide more resistance to the products. We operate in different sectors, as I mentioned. Biggest ones are automotive and construction, and go into more detail within the construction industry, which would be more relevant to yours, is that we have Dramix, which is steel fiber reinforcement for concrete, Stukanet, render reinforcement, and as you know now, masonry reinforcement, one of which is Brickforce and Murfor Compact. Murfor Compact, as Martin explained, is a new generation of bed joint reinforcement. It comes on a roll and it can be cut to size. It consists of high-strength steel and allows for smaller section and lighter reinforcement because of the high strength of the steel. It has CE certification for structural and non-structural use through ETA 180316. This product has taken us quite some time to develop. It's taken about 5 years to develop, and it has taken a lot of investment from us to come out with this revolutionary product. There are various types to Murfor Compact. There is A, I, and E. Each has its own specific application. A, for example, is produced for or mainly used for AAC blocks. I is for internal blocks, and E is for external leaves. The difference between the I, A, and then E is that the I and A are galvanized, whereas the E is stainless steel, which means that it can be used for external leaves where you have exposure to the elements, wet elements, etc. Here are the properties of the reinforcement, where you can see to the right that yield strength goes up to 1717 for the A and I. When you compare this to the traditional reinforcement is roughly ranges between 400 and 600. The high strength allows us to use a much smaller cross section of the reinforcement to achieve similar kind of strengths, which also means that it can be lighter, it can be easier to transport, easier to store, etc. Moving on to the applications, for example, we have lateral loaded panels. The Murfor Compact can replace wind posts where it can reduce the initial cost and labor costs of the masonry reinforcement. That is due to the fact that you don't have to stop construction in order to install the wind posts. You just roll out the Murfor Compact and cut it to size. A big application for the reinforcement here in the UK is extending movement joint spacing, which has an aesthetic pleasing application. Crack control around windows where you have stress concentrations that usually cause diagonal cracks. We apply Murfor Compact in these situations in order to mitigate and stop these cracks from occurring. Further applications include lintel support, where the reinforcement actually replaces traditional steel lintels, where you have stack bonded masonry. Eurocode states that reinforcement should always be used where you use stack bonding the masonry. Also, we have facade supports and differential settlements. Reinforcement will mitigate crack occurrence in this situation. Moving on to the ULS design, similar to reinforced concrete design, when windows are applied to the panel, you'll get a compression and a tension zone. Through mathematical calculations, then you get the neutral axis depending on the geometry of the reinforcement as well as the thicknesses of the leaves and the properties of the material used. From the neutral axis, you then calculate the resulting moment and the resisting moment in turn, as you can see. The advantage, so comparing to the traditional reinforcement, advantages of Murfor Compact is that it is quite lightweight due to the high strength. It's easy to handle and on-site storage compared to traditional reinforcement. You can apply Murfor Compact on dry bed instead of having to apply a layer of mortar and then reinforcement and then another layer of mortar, which actually shortens the program quite considerably. Able to cut to size, meaning that you have less material loss of the reinforcement, and also that because each roll of Murfor Compact is 30 meters, you will overlaps are only needed every 30 meters. When you compare this to 2.7 meters in traditional reinforcement. So that was briefly about us as a company and Murfor Compact specifically. If you have any more information, if you have any more questions, just let me know and I'm happy to help. Thank you very much. Back to you, Martin.
Thank you very much, Yasin, for that overview of the Beckhardt product. And yeah, well, hopefully now you can see why we were particularly excited about this product, and we think it really does offer a lot to an excellent alternative to traditional bed joint reinforcement. So I'm going to break out of this presentation now. We'll not bore you too much more with PowerPoint and its presentations. We're just going to get struck straight into the demonstration of the MasterKey Masonry product. For those of you who aren't familiar with MasterKey Masonry, MasterKey Masonry is a individual design module that's available within the Master Series design range. Our company is Civil and Structural Computer Services. We've been developing structural engineering applications for over 30 years now. And MasterKey Masonry has been in development now for over 20 of those years. So it's been a very popular product in the UK and further afield, and hopefully the extension of the various European national annexes will see its popularity improve and extend throughout the European continent. Of all the various national annex countries that we have implemented, we're delighted to consider further countries. We see questions there about whether we would plan to include the Turkish national annex, and with the systems that we have, the implementation of further national annexes is something that can be done in quite a quick turnaround time, and it's something that we would certainly consider if the expression of interest was raised. So thank you for that question. So we're going to get stuck straight in. As I say, the Master Series range, the MasterKey Masonry is just one component of a wide range of analysis and design software. The MasterKey Masonry can be purchased individually as a standalone module. You don't have to purchase the entire Master Series range to receive that. And we access the MasterKey Masonry through the drop-down menus, or conveniently, if you're working on a recent file, you can access that directly from the front screen, which is what I'm going to do just now. So opening MasterKey Masonry, again for the uninitiated, I'm going to take a quick overview of the product and its workings in fundamentals. So at the top we've got some toolbars with some quick access of turning off and on various things like piers, cavity walls, all of which can also be accessed at the bottom. The design interface is such that you have a graphic followed immediately by the full set of design calculations as you would see them on the printed page, and in fact the design calculations summarized in the output screen closely represent the design output that you get in your actual design report on the printed page. And nothing is hidden. It's what we call real-time design. What you see is what you get, and all of the changes that you make are updated instantaneously in the design output, meaning that you are very much in an interactive design mode, in that every decision you make, you see the effect of that change, and you're better informed then for your next choice. All of the input is carried out using the tabs at the bottom. You can have various walls within the one file. We call these design briefs. So I've got one wall in this file. I can certainly add further wall panels and have a collection of wall panels all contained in the one file representing perhaps an individual project. All the various inputs of the walls are conveniently contained in the tabs along the bottom. In this instance I've got a cavity wall, and here I have the basic dimensions of the wall panel and the facility to alter the leaf condition fixities. So for instance, on the base here I've got a fixed bottom, so I can click on the symbol and change that to a pinned support or even a partially fixed support, and back to pinned. So moving on through the other tabs, we've got tabs for material and loading for the inner leaf, material and loading for the outer leaf, a further tab for the application of lateral loads, inputs for wind posts if you so desire that's what you want, inputs for openings, and also finally bed joint reinforcement. And we're going to take our work through those as we go very quickly. The first thing really to draw your attention to is the technical sophistication of the MasterKey Masonry product. Of course, we're designing to various British and European standards, and in this instance we're designing to the Eurocode 6, the BSEN 1996, and here we can choose the inbuilt countries that are available, and we're going to do some switching around of that in just a few minutes time. However, although we're designing to Eurocode 6, one of the challenges with the design codes of practice are what do you do with walls that have more sophistication when you've got multiple openings, perhaps some piers, wind posts, and the analysis of those walls for lateral loading. MasterKey Masonry took a huge leap forward about 3 years ago with the introduction of advanced yield line analysis technology. So rather than relying on the tables in the code to develop if you like, a moment modification or a calculated value or a tabulated value for the calculation of the applied moment, MasterKey Masonry is using sophisticated linear programming based yield line analysis techniques to arrive at the most critical yield line pattern for a variety of wall shapes with openings way over and beyond what you can otherwise achieve through the standard codes of practice, but still adhering to the principles laid down by the code in terms of using yield line analysis for the calculation of the applied forces. In this instance, we can see the yield line patterns that are produced. The blue yield lines represent a negative or a positive yield line, whereas the green ones represent a negative yield line. That can be either drawn or not drawn, although we do recommend that you keep that on the screen so you have a good appreciation of the yield line pattern that is produced. So for instance, we can see the changes dynamically occurring. If we change the base to a pinned, the yield line pattern automatically updates itself and is calculated accordingly. Interestingly, if we were to switch off the yield line analysis and use the codified tabulated values, we don't now get a yield line analysis, but we do see down here our unity ratios of the moment capacity. And that's another nice feature of the design output interface that we haven't yet covered. Of course, you can go down through the design output and see how the various aspects of your design are performing, but you can also glance at the unity ratio bar and see down here that the 0.877 unity ratio is down here. Turning back on the advanced yield line analysis, we can see that that unity ratio changes slightly. So there's very good correlation between the codified values and the numerically calculated values through the advanced automated yield line analysis. Let's just turn on the base fixity again so we have that fully fixed. Really, the benefit of the advanced automated yield line analysis comes on board whenever we want to move beyond the basic shapes or basic rectilinear wall panels that do not have openings. Because of the advanced yield line analysis, we can have openings of various arrangements. Now, the code methods obviously lay down techniques to deal with openings based on sub-panel methodologies. However, I think it has long been established that those are very conservative in their approach in terms of how the walls are split up and how the loads are transmitted from one sub-panel to another. With the MasterKey Masonry design, the full yield line analysis is arrived at more or less instantly for whatever arrangement of openings that you can think of. So we have up to 9 additional rectilinear openings able to be input into the software. So you can see here the introduction of these 2 openings has caused the design to fail. Now, a quick note on the yield line analysis is the methodologies and way in which the yield line is performed uses a numerical background of linear programming in conjunction with a proposed set of density of possible yield lines. The density of those possible yield lines can be altered in the software, and it's important to be aware of the underlying technology that's at use. So with a coarse underlying density of yield line, we arrive at a yield line pattern, and the software gives us a unity ratio, which in this case is just about failing by just under 1%. If we were to change the underlying density of the elements used to arrive at the mesh or at the yield line pattern to a medium density, we can see in this instance that hasn't actually made any difference. Let's go for a more refined mesh. In this instance, because of the increase in density of the meshing, it does take longer to analyze and is less instantaneous, in which case then the option is available to then perform an analysis as opposed to the analysis being dynamic with every single change of input data that's made. So there is that distinction once you get up to the more refined. However, we have found through various walls and the studies of hundreds of walls that the difference is actually between a pretty coarse mesh and a superfine mesh in terms of the percentages of difference are in a very small range of a maximum of 5%. what you find is if this wall were at a unity ratio of say 0.99, just about failing, and you were using a coarse mesh density, we would advise that you, in the software, in the output, that you increase the mesh density to ensure that the most critical yield line pattern has been achieved. In general, it's perfectly acceptable to remain at a coarse or a medium mesh density, and only perhaps think about going up to a more refined mesh density if you are within 5% of the failure. And the software does take care of that advice and gives you that advice in its design output. One of the things that you might find often very useful, as I say, this is dynamically updating the analysis of the wall as I make changes, as I would put in changes to the thicknesses. We can see these things happening instantaneously. However, in some instances that is something that updating that calculation of the yield line with every single change is something that perhaps you don't always want, and you want to expedite your lots of inputs that you've got to make and then decide to analyze the wall. You can of course turn off the auto solve and just decide to do the solving of the yield line analysis when you're ready to do so. In this instance then, as changes are made, if we change the wall thickness back to 100, we can see that the there is something else going on in the background in that the yield lines are cached, or the results are cached. So if I were to change that to something that hasn't been analyzed before, you can see that because I'm not auto-solving my yield line, it does say, okay, everything's calculated in terms of capacities. However, for the arrival of the plastic analysis yield line unity ratio, you do need to then to do your solving. I'm going to continue with that option turned off so that we can put in lots of input and just solve when we know we're ready. Excellent. Okay, so what I'd like to do now is just pop these openings out again and have a look at the implementation of the new features in the software of bed joint reinforcement. If I were to take this wall, currently we're designing to the UK National Annex, and what we have discovered with the implementation of all the various national annexes is that good news for the UK, we are fairly generous in the flexural strength capacities of FXK1 and FXK2 compared to lots of our European counterparts. So in this instance, for instance, we are getting for our outer leaf, which is clay, and our clay material here dictates that it's less than 7% water absorption, which is an input which is unique to the UK National Annex, which does drive and change the FXK1 values. If I were to change that to above 12%, and let's just resolve that, we can see those values decreasing, and now actually we've got a failing wall. We'll put that back to the 7%. So a couple of the changes that have taken place, which existing customers need to be aware of, is the design interface has changed here and is more descriptive and hopefully informative and helpful in terms of all the various inputs. Inputs for execution and category have been separated out into their own classes, but the biggest change probably is how the mortar has been designated. Previously, the inputs in the software allowed you to select only the prescribed mortar. That was defined in the UK National Annex and Irish National Annexes. However, with the variety of prescribed mortars in all the different European countries, this system is a little more open now, in that, yes, of course, you have the prescribed mortars that are relevant to the European National Annex that you're working with, but in addition to that, you also have the option to select a general purpose mortar, where this would be a design mortar typically, where you simply specify the grade of that mortar. If this is a mortar that isn't one of your prescribed ones that are detailed in your country's national annex, you can still have the choice of using another value of mortar other than the ones that are standard to your European national annex. In addition to that, the use of lightweight mortar is different as well. Previously there was a checkbox to say you wanted to use lightweight mortar. Now they are separated out into their own mortar designation. So you've got lightweight mortar of the two various densities, less than 1300 kilograms per meter cubed and less than 800 kilograms per meter cubed. as they are given a distinction in some of the calculations. You've also got a separate option for thin layer mortar, again where it is your responsibility to specify the strength of that thin layer mortar. So those are some of the changes that have taken place there. I'm just going to come back to my M2 mortar in this instance. So we're still designing to the UK National Annex, and let's just update the analysis there again, and we're back to a passing situation. I would like at this stage to move over to a different European National Annex, and let's go for the home of Beckhardt, who are based in Belgium as their central head office. So let's have a look there and see what changes are afoot. Now immediately the list of available prescribed mortars change to what is specific to that European National Annex, and these are a little different. When changing from one European National Annex to another, the MasterKey Masonry does its very best to pick an equivalent or lower grade mortar from the prescribed one that is available. So we see here we've changed from a 2 to a 2.5. If there were a value available that was less than 2, it would have chosen that. But this is the minimum grade prescribed by the Belgian National Annex. So this is the one we've gone for. If you want to specify otherwise, you still have the choices for general purpose where you can specify your own FM value for the masonry. Now with regards to the Belgian code, it does matter actually whether it's a designed mortar or not a designed mortar. With regards to the calculation of the gamma factors, we have the classes specific to the Belgian National Annex. The categories are as per the standard Eurocode norm of 1 and 2. And we can say here, for instance, yes, we would like to use a better execution construction class of S. And that's for the inner leaf. And let's just change back to N. So we can see 3.5 and 3.5. The S takes us down to 3. Let's use unit categories 1, and we can see if we weren't using a designed mortar, again that has an impact and is influential on the calculation of those gamma factors. Let's actually increase our strength as well to something a little bit more beefy to try and maybe get over this problem. And I'm just going to do a solving of the line analysis, and immediately we can see quite a considerable difference between the Belgian National Annex and the UK National Annex, in that the default values of FXK1 and 2 are more equivalent to the Euronorm values and are certainly much less generous. In fact, you can see here we're actually using not the Belgian National Annex at this point, because the Belgian National Annex says that it's only applicable to mortar grades above 10. So if I choose a 12 mortar grade for the inner leaf, we can see here that now that it is actually using the appropriate table in the Belgian National Annex for the calculation of FXK1 and 2. And let's do the same for the outer leaf material, that is, and it's a clay, class N, category 1. Yes, that's what I want, and I'll go for an M12 mortar, and it's also designed. And a couple of other inputs here that haven't been specified as yet is the density of the material, the unit height of 65, and the least horizontal dimension of 102.5 is actually pretty important. Some countries' national annexes, the actual unit dimensions are more important than others. In the Belgian National Annex, certainly for Group 2, these are pretty important even in determining the compressive strength, because the shape factor comes into play and is calculated, and all of that is picked up by the program automatically. So let's just go back to Group 1 clay masonry units. In some countries as well, the specification of the overlap of the units is particularly important for the calculation of the FXK2 values, however not for the Belgian National Annex. However, I think it would be good practice just to specify a value of 65 there, because as we switch maybe over to other national annexes, that value may indeed be important. So yeah, it's a good idea to have those values set up accurately. Let's do another analysis here. We should find we're a good deal better than we were, but we're still in a failing situation. Obviously, traditional intuition might lead you to say, well, I would like to try to insert a wind post, and we can easily come and do that. I've got one set up here at 2.5. It's a channel section that's available from our standard library of steel sections. You can choose from a variety of sections. I'm working with a UK library of steel sections, but Master Series also has libraries for European standard section sizes as well as other parts of the world. So these are the ones available to the UK, but they can be European specific ones as well if that's a setting that is made. In this instance, we've got a 152 by 89 channel section, which is bending about its minor axis, which is why when we look at it on plan, we can see it orientated in this fashion. Now, the location of that channel doesn't have to be on the outer face or of the interior leaf. It can be in the cavity. It doesn't actually make any difference to the analysis that takes place, because the analysis that takes place here, as you can see, it's resulted in the yielding of a panel to one side of this here, and immediately we've got a much more favorable lateral strength because of that. However, if that were something that you desired not to have for some of the reasons that Yasin outlined, we of course have the option to go for the reinforcement. So with bed joint reinforcement, you users of the software will note that there's some changes in the design interface here as well. Much more favorable and easier to use and let out. We simply say, yes, we would like some reinforcement in our outer leaf. If you want to use the user-defined method of providing 2 bars, 2 3mm bars at 60 mil centers, perhaps at 450 vertical centers, that's on the outer leaf. Let's have a look, and we can see that coming into play. All of the design calculations are here for you. You can see the calculation of your Z value, and the checking of the minimum bed joint reinforcement is specified there as well, and that's all okay. And if we can analyze this, immediately we can see the flexural strength is 0.485. Actually, still not quite enough. If we were to take that off completely, we can see the previous flexural strength was for the FXK2 direction 0.35. I think there was a question asked there with regards to how we are utilizing the bed joint reinforcement, and it's worthwhile noting that although the Murfor Compact and various other bed joint reinforcement products can be used for in-plane increases in the lateral in the in-plane strength of the wall for perhaps lintel design or in-plane local stresses around openings, our use of bed joint reinforcement in this version of MasterKey Masonry is limited to the enhancement of the lateral strength of the wall, so really only for the benefiting of lateral strength. However, we do plan to introduce facilities to do reinforced masonry lintel design, hopefully in the not too distant future. So these are for the use of with lateral loading alone. Our lateral loading, incidentally, is specified over here of 0.7 kilonewtons per meter squared as a characteristic value. But back to the reinforcement tab. Let's now go away from the user-defined approach and have a look at our new bed joint reinforcement library. So we can see various products here, and the Murfor Compact there is available right at the top. So with the Murfor Compact, we've got inbuilt all the various categories of the product that Yasin outlined. If, for instance, you did use something like an A40, which, as Yasin explained, was something that's specifically set up for autoclaved or rated concrete products, we will note here in the output that each of these products in our database has design notes associated with it. So we can say that these are only for use with autoclaved or rated concrete blocks, and you should pick that up in the output. But if you're familiar with the product that you're installing, hopefully that will not be a confusing matter for you. So because we're dealing with the outer leaf here, obviously we've got the inner and interior and exterior grades as mentioned. So these are the galvanized, these are the stainless steel. If I did choose an interior one, even though this is for an exterior leaf, we will see that the design notes tell that it is galvanized steel and it's internal use only, or as per Becker's specification, for use with 15mm external render, if that is appropriate. But I'm going to go and use an E35, which is a 35mm wide stainless steel product, specific for the exterior leaf, which in my case, as it's clay, is not going to be a rendered surface. And as we look at the design output, we can see immediately that the calculations that are taking place. We numerically arrive at the appropriate neutral axes of a balanced section between the compression and the tension zones. and then we work out obviously what the strains and hence stresses and contribution to moment capacities are from all the various strands of reinforcement. This E35 product has 5 bars. The maximum steel strain of the extreme bar or extreme wire is this percentage. So that gives you an indication of whether you are under reinforced or over reinforced, and the compressive strain in the concrete or the masonry is given there as well. And we can see that the increased moment capacity that is arrived at of the 0.59. Now straight away obviously we have an issue with regard to the percentage of reinforcement, and for the E35 I think we're going to need to go down to it being placed every other course of brick at 150, so that you can obviously specify that and have the appropriate amount of minimum percentage of reinforcement there. And straight away your capacity actually increases to about 1 kilonewton per meter squared as well. If we do a solving of the yield line analysis, we can see in this instance that's been enough to make the wall past reinforcement in the outer leaf only, and I haven't specified any reinforcement in the inner leaf. Alternatively, if you're able to, you can use the 70mm wide product, and in this instance we're more than likely be able to stretch that up to every other course. But in all instances we would recommend that you refer to the manufacturer's guidelines in terms of each of the products and its usage. And this is where the link to the product data sheet is particularly useful, and that's opened up on my other screen, but that will certainly bring you to a pretty close place where you can get a bit more information on the product that you're using, or request a technical data sheet on that from the manufacturer, and that's available for all the various proprietary products that are inbuilt in the MasterKey Masonry database. So let's get rid of that. Okay. Now if we decided not to reinforce the outer leaf but to go reinforce the inner leaf, of course we might use the inner leaf capacities, and I'm just going to solve there on that. And again that's been enough, and we've got a little bit more on that because it's a 50mm wide placed every 150 centers. Looking at the inner leaf in terms of minimum percentage of reinforcement, yeah, that's what we would need. Interestingly, if we were to say we want to make this leaf a little wider, 200, we also have the opportunity to say that we would like the reinforcement placed in pairs. So we're going to have 2 products of 50mm placed in parallel at a spacing of 20mm, and in this case this immediately increases us from 14 bars to from 7 bars to 14 bars. So we just do the solving of the yield line analysis there. We can see that overall we've got a 50mm wide product with 7 bars, this yield strength, this E value, 2 number placed in parallel, spaced at 20mm apart, always centrally located on the leaf. And in this instance actually, although we've got 14 bars, only 13 of the strands are in tension due to the calculation of the placement of the neutral axes. So that's another option that's available to you there. We are always observing the limitation of the lateral enhancement to 50% as well, which is why we've got 2 yield line analyses going on here, an unreinforced yield line analysis with a reinforced yield line analysis. Obviously in this instance with the increased leaf thickness, the provision of the reinforcement actually wasn't necessary, but obviously depending on your load that may be a very viable solution to you. Okay, so having a look at perhaps some of the other national annexes, let's keep the outer leaf reinforced, as I think this really offers the best solution for this particular scenario, and we'll just drop that inner leaf back down to a 100 thick leaf, so we're a bit more utilized. Coming across to some of the other European country national annexes, for instance the Netherlands national annex will require some additional input if you so desire, for things like, so you can see the specific classes for the Netherlands national annex coming into play there, along with its particular prescribed mortars. And in addition to that, if you so desire to specify the bond strength and the unit bending strength of the material, a more refined calculation according to the Netherlands National Annex can be carried out for the FXK1 and FXK2 values. If you do not specify those, the software as dictated will default back to the Euronorm values, and that's fairly typical of the behavior of the software. If a particular scenario or set of values aren't provided, or the or is outside of the scope of the particular national annex chosen, the general rule is that we will default back to the Euronorm values, and those will be indicated as such when looking at the references here. You will know whether those are the Eurocode norm references or whether they're the references specific to your country, such as the table NB1, which is a table straight out of the Netherlands National Annex. A couple of other things to note is if we switch across to the German National Annex, we will see straight away some of the changes that are afoot here. Different prescribed mortars to start off with, as well as the prescription of the lightweight mortars and the thin layer mortars, all as per the specification of the German National Annex. As well as that, for each of the types of mortars, you also have the variety and quite extensive range of the different masonry unit designations for each of the materials. So, for instance, for the outer leaf material, for clay, we've got all the HLZA, ZB, various types. And if you look at the German National Annex, and if you're operating in those design environments, obviously you will be well aware of what these unit types represent in terms of their groupage, but all of that is observed and taken into account automatically by the software. A huge issue just to point out with the German National Annex is if we were to come across and look at the outer leaf reinforcement, the provision of the these values, let me just take that out altogether there and do a solve. The default values for the gamma MC and the gamma values for the reinforcement in reinforced masonry in the German National Annex is indeed 10, and that's a value that is specified. However, as per the National Annex, you do have the option for locally agreed values. So if you are designing for reinforced masonry to the German National Annex, we do observe the default National Annex values. However, you do have inputs to specify your own value. So if a locally agreed value of 2 was specified there, perhaps the more normal value of 1.15 there, we can see those now being taken into account in the software. And we'll just do a solve there to update that. We're still in trouble. In this particular scenario, we may need a thicker leaf or more reinforcement. But that's all observed and taken account of. So you do need to be aware of the inputs that are required for the different national annexes. For the German National Annex, certainly the unit overlap is used for calculating the some of the flexural strength properties. So those will need to be, you make sure that those are observed. Ladies and gentlemen, we've come to the end of the introduction of the provision of the bed joint reinforcement library in the MasterKey Masonry, as well as a quick overview of some of the design national annexes and the various options that are available with those, and the things to be aware of when switching between the national annexes. Ladies and gentlemen, I'd just like to finish by thanking Beckhart for their involvement in helping us to expand the MasterKey Masonry in this way, both with the implementation of their products and also with the extension of the various national annexes, and also for you guys for attending and for your time and attention here today. So once again, thank you very much for your time, and we look forward to seeing you at the next webinar.